Okay, good afternoon, ladies and gentlemen. So this is day one of the polynomials, okay? So in this section, we're going to be asked a bunch of different questions involving polynomials, all right? So far we've seen, we call these monomials, where it's just one term. Okay, those are monomials for one. We've seen binomials, which is just two monomials joined by either, addition or subtraction. Okay, and then the last one is trinomials. Whoops, forgot something. Uh-oh. Pen's starting to die here. I'm running out of ink, ladies and gentlemen. So, as you can see, there's three there. There's three monomials. Okay, so hence the name trinomials. Okay, and they keep getting bigger as you go. But these are the ones that we've at least seen thus far. Okay, so those are pretty much the only ones you're going to be having to worry about for the duration of this section here. Okay, yes, if you scroll down here, I'm not seeing anything more than, oh, we got an x cubed in here, but, so this is, a little bit larger than a trinomial. As you can see, we have 4 monomials in there, but, anyway, so that's what we mean by polynomials, okay? They're just, monomials joined together, and depending on how many they are, will determine its name, but they all fall underneath this category of polynomial. Okay, so let's take a look at number 1. All right, so let me scroll in here. All right, I'm still getting used to doing these videos here, guys, so just bear with me. I'm trying to make it as good for you as I can. So, Fred is given a rectangular piece of paper. If the length of Fred's piece of paper is represented by 2x minus 6, and the width is represented by 3x minus 5, then the paper has a total area represented by one of these 4 options. Okay, so they give us the length, all right, and then they give us the width. Okay, but let's talk about what it means to find the area of a rectangle. Okay, first let's just even go back. Let's talk about, boy. Okay, there's squares. And there's rectangles. Let me get a better square here. That was just going to bother me. I don't know why I'm having trouble here. Last try. Perfect. Okay. So, in order to find the area of a square or a rectangle, if you guys recall, okay, they either had the formula listed as length times width, also maybe heard it as base times height, okay. So if you recall about the square, okay, all the sides of a square are equal. So it pretty much was just the side squared. So the area of a square is really just side squared, but it's still base times height, which in this case is 4 times 4, which is 16. Okay, to find the area of a rectangle, whoops. Okay, same process, right? In this case, let's say the length and the width was, let me put some colors in here. So let's say that the width was 2, and this was 4. Okay, so our area here would be 2 times 4, which is 8. All right, and usually they give some sort of unit, so let's just say this is meters. All right, let's say this one is in meters as well, so you would say 8 meters squared. This one would be 16 meters squared. Okay? Now, we're not actually given any numbers over here. Right? We are given a couple binomials. Okay? but our process is still the same, all right? So let me draw a rectangle again here. Good enough, okay? So here is our length. And here is our width. Okay? In order to find this area, we're going to have to multiply this and this. Okay? So you're going to have 3x minus 5 times 2x minus 6. Apologize, guys. I'm having issues with this pen here. Okay. So, a lot of you guys use the arrows, okay? Which is fine with me. So your first one is 3x times 2x, which is 6x squared. We got 3x times negative 6, which is negative 18x. We have negative 5 times 2x, which is negative 10x. And negative 5 times negative 6 is a positive 30. Combine like terms. And voila. Okay, it's in standard form. As you can see, our degree for each monomial goes down. Don't forget the degree is just counted by the exponents here located to the right of your x's here. All right, so in this case, this degree is 2, this degree is 1, and this degree is 0, okay, because we don't have any x's located next to our number here. Okay? All right. And again, if you don't remember how to find degree, all right, we will touch base on that as we go, okay? So, anyway, let's take a look to the right and left. Do we see our answer? We sure do. Okay, cool. I feel pretty good about that. All right, and let's move on to the next one. Okay. So it says, when factored completely, the expression p to the 4th power minus 18 is equivalent to one of these options. Okay? So let's take a look at p to the 4th minus 81. Now this is a particular problem we've seen. It might not be recognizable because we haven't talked about it in a while. But this binomial has a special name. Okay? And it's called a difference of two squares, aka dots, okay? Or dots if you prefer to call them perfect squares, all right? And so our numbers that are perfect squares go as follows. So it is 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 169, 196. Oops, I forgot one. It's been a while for myself here. 144, that's 12 squared. 169 is 13 squared. 196 is 14 squared. 225 is 15 squared, and 256 is 16 squared. Okay, those are our perfect squares that you kind of want to focus on for this problem. All right, at least that's what we're looking for. And as you can see up here, we do have one of those numbers, don't we? 81. All right, so 81 is one of our perfect squares. Right? But the one that doesn't look so recognizable is p to the 4th, okay, because it's raised to the 4th power. So it doesn't really quite look like a number squared. So let's think about this for a second. So let's go back to just simplifying this for a little bit. p squared minus 81. All right, so if you don't remember what a difference of two squares problem looks like, what happens is you take a look at these two numbers. So is this some number squared? Definitely. All right, we don't know what the number is, but it's being multiplied by itself. That's what p squared stands for. P squared just stands for p times p. All right, and as you can see, we've already discussed this. 81 is one of our perfect squares, which is 9 times 9. So what happens is you end up splitting these things up. Okay, put a p on each side, plus and minus in between, and then you take the square root of that number. All right. Now, another key part about the difference of two squares is difference. All right, you have to have the minus sign in between. Okay, because what happens was when you multiply these numbers together, if we were to multiply them back, right, then we get p squared minus 9p plus 9p minus 81. And what happens is these numbers cancel in the middle, and you're left back with this binomial here. Okay? Another trick to look for here, and go back up here, erase some of this stuff. Okay? Let's take a look at this number right here. It's 2 divisible by 2? Absolutely. Right? It equals 1. So as you can see, we put 1p on each side. All right, going back to our original problem, okay, we have p to the 4th. All right, so think about this. P to the 4th is just actually p squared times p squared, right? Don't forget our exponent rules. When you're multiplying something that has the same base, you add the exponents, and 2 plus 2 is 4. All right, so we actually do have the difference of a difference of two squares problem. Okay, we have a minus sign in between. 81 is a perfect square, and as you can see, all right, p squared times p squared is just p to the 4th, but p to the 4th is two numbers being multiplied by itself, just like up here. Okay, so we do the same process. So we split these up, okay, because don't forget, 4 divided by 2 is 2, which means we put a p squared on either side. Okay, hopefully that doesn't confuse you too much. You put your plus in the middle in between, whoops. Right, and then what's the square root of 81? It's just 9 and 9 on either side. Okay, and we do see that answer to the left here. All right, so you're probably thinking, well, good, we're done. Do not fall for that, ladies and gentlemen, okay? And this one's completely wrong then, because if this one's wrong, then this one's definitely wrong, because that is not what we have here. So it's got to be one of these to the right, or the left here. It's got to be one of these, okay? And so one of these is wrong, and I'll show you which one is wrong here. So let's take a look here. Get a different color. So, is this some number squared? Well, sure is. Is this some number squared? Absolutely, right? That's right over here. That's 3 times 3. Okay, but what don't we see in the middle? We don't see a subtraction sign, but we do see that right over here. Okay, so this one, don't fall for it. Okay, difference of two squares has to have a minus sign in between. We do have two perfect squares here, but it is a sum. So we have to leave this one alone. Okay, but take a look over here. We got some number squared here, some number squared here, right? That's 3 times 3, and we do have a subtraction sign in the middle. So this is, again, another difference of two squares. So we have to split this up again. So we split the p's up now, okay, because there's 2. So take 2, divide it by 2, you get 1, so that means you're going to put 1 p on either side, plus or minus, and the square root of 9 is 3 times 3. And that is your final answer. So as you can see, they wanted you to split this one up. This is a regions problem, so you got to be careful with these guys, okay? Because they'll lead you down the wrong path. Trust your instincts. And there you go. Okay, so just be careful with those difference of 2 squares problems, because sometimes you might not be done. And it's also important to try to memorize some of these numbers here, guys, because they're not going anywhere, especially if you decide to take Algebra 2. Okay, moving on. Number 3. So it says, subtract 5x squared plus 2x minus 11 from 3x squared plus 8x minus 7. Okay? So, let's think about this. So, first thing we've got to come up with is which one goes in front. Subtract which one from which one. So let's just go back to one of my examples I've used in class before. Okay, if I said subtract 5 from 10. Okay, simple. Just subtract 5 from 10. You, hopefully, would go 10 minus 5, right? Subtract 5 from 10. All right, so 10 minus 5, you would get 5. All right, think of the same process here. So subtract 5x squared plus 2x minus 11 from this one right here, 3x squared plus 8x plus minus 7. So this one will go first, and this one will go in the back. All right, so sometimes it's easier I know these big long trinomials here, because as you can see there's three terms. Right? Sometimes these, sorry guys. Sometimes these, these big trinomials can kind of confuse you, but just sometimes it just helps to just simplify the problem. Think of something we're familiar with. All right, take 5 from 10. All right, it's 10 minus 5. All right. So in this case, subtract this from this means we're going to go 3x squared plus 8x minus 7 minus, now this is where you got to be careful as well. Notice I put parentheses around this trinomial. Okay, it's important you do that because we're subtracting this by this whole piece. All right, so we actually have to switch the sign in this particular polynomial. Okay, so that's why it's always important to make sure that you're always putting things in parentheses in these sort of problems. Okay, so when I say subtract 5 from 10, subtract this from this, okay, you want to make sure that this whole trinomial, you hug it with your parentheses. Okay, so that means we're going to have to distribute this -1, in which case we're just switching the signs. So 3x squared plus 8x minus 7 minus 5x squared minus 2x plus 11. And then now we just combine like terms. So let me get some different colors in here. All right, so this one, we'll go with this one. Ooh, gotta keep that sign in there. Okay, this one, we'll go with this one. And the constants, go with the constants. Okay, so our final answer is -2x squared plus 6x plus 4. Okay? Let me check my math there. So 3x squared minus 5x squared, that's -2x. 8x minus 2x, that's 6x. And 11 minus 7 is 4. Happy. Okay? And there's your answer, folks. Okay. 2 more problems here, guys. Let's take a look at this one. Let me get rid of some of these things in the way there. Okay. So it says, which expression is equivalent to 2 times x squared minus 1 plus 3x times x minus 4. Okay? I'm going to shrink this back up here just a little bit so I can give myself some space here. Oh, crap. I'll just delete all that anyway. It just gets in the way. Okay. So, here's what we're looking at. Okay, so we need to simplify this expression here first. Okay, so what you want to do is you want to distribute. All right, so I'm going to go 2 x squared minus 2 plus 3x squared minus 12x. And check my math. There's 2x squared minus 2 plus 3x squared minus 12x. Okay. And then all we have left to do is just combine like terms. So we have this one here and this one here. That's going to give us 5x squared. And then we have minus 12x. And then negative 2. Do we see that answer? Sure do. Okie doke. So, I want everybody to take a look back at these numbers again, because they're going to come important in this particular problem again. So let me see if I can drag these down here. Cool. Okay. So here we go. Let's see if I can zoom in just a little better. Alright, so it says this expression 16x squared minus 81 is equivalent to. Now, why would I bring these down here? Just for fun? Just to be silly? No. Okay, this is another difference of two squares problem. Okay, so these numbers, 16 and 81, as you can see, both appear on the right side of this screen. Okay? So, our job here is to just kind of split this up with a plus or minus in the middle. All right? So we have an x squared here, so let's start with that one. So that means we're going to get an x on either side. Okay? Now, let's look at 16. 16 is just 4 times 4. Right, so that means we're going to put a 4 in for both of those, in the front of the x, I mean. All right? And 81, which we've seen before, is just 9 times 9. Okay? If you're wondering, how did you know it's a difference of two squares problem? Again, these are two perfect squares, and the key is this subtraction sign, okay? If that was a plus in there, we couldn't do nothing. We wouldn't even be able to take out a GCF. All right, so I guess that's another important thing to bring up that we haven't seen here yet. Let me take a scroll back here. I don't think we've had any problems. We start out with a GCF. Nope. Okay. But in every problem here, guys, you want to make sure to check to see if there's a GCF. Okay. Between these two, there isn't. All right. But it's important to get into that habit, you know, so just in case this was maybe like, you know, 5x squared minus 10, we'll say, sorry, just to stay with our difference of two squares problem, 20, okay, you don't recognize it's a difference of two squares problem at first, but when you take out your GCF, which is 5. Okay, you want to take out a common factor for both. Take out a 5 from each, and voila. We have negative 4, which is the difference of 2 squares problem. So just, we haven't encountered any problems like that, guys, but just check to make sure if there's a GCF, okay? I apologize for not bringing that up sooner, but we don't see one here. Okay, between 16 and 81, there is no GCF. All right, and so take a look at these numbers here. Do they look right? I would say so. 4x minus 9, 4x plus 9. Now, if you don't believe me that this is this problem up here, right, or if you just don't believe yourself, if you're like, man, this looks weird, right, well, multiply it out again. Right, so 4x times 4x, well, that's 16x squared. 9 times 4x is a positive 36x. Negative 9 times 4x is a minus 36x. And negative 9 times 9 is minus 81. And again, what happens? These two things cancel in the middle. Whoops. That's a bad 8. Bad looking 8. And there's your answer. Okay? So if you're ever unsure about these problems, guys, you can always multiply this back out just to check to be sure. All right? But a key problem, anytime you see a binomial here, guys, always check to see if there's a GCF and check to see if it's a dots problem. Okay? Because there's a good chance that it probably is at least one of those. You can either take out a GCF, which is the greatest common factor, okay, or it's a difference of 2 squares problem. Okay? So anyway, there is day 1, problems 1 through 5 in the polynomial section. Okay, so stay tuned for more videos this week, you guys. Any questions or concerns, or say, Mr. Kaya, I need some further help, feel free to email me, guys, please. All right? Don't